Hello everybody, and once again welcome to Pankaj's Echelon tutorials. And in this today's video, I'm going to discuss on IGCSE curriculum, and the subject is mathematics. So let me write down for you. It is IGCSE, and the topic is mathematics. The subject is mathematics. Okay. And of course, I use the David Rayner book. Okay, so I'm using this David Rayner book, and in this David Rayner book, you have a chapter number 9, and the name of this chapter is matrices and transformation. Okay, and this is the 4th edition that I'm using. Okay, so matrices and transformations. Okay, now this is the name of the chapter. It's a very interesting chapter. At the same time, it's a bit lengthy also, and there are a lot of concepts involved in this chapter. And mainly, you have to study this chapter in 2 parts. That is transformations and matrices. So there's something called matrices, which you have to study separately, and transformations you have to study separately. Then you have to combine both the things. Okay, both the concepts, right? So this is the thing that I'm going to start with in this video. And as I told you, this is a IGCSE curriculum ka chapter. So let us get started. And let me tell you that right now I'm going to discuss only the transformations. Okay. So matrices and transformations, the name of this chapter, and you have to understand what are matrices, what is the meaning of matrices, what is the algebra related to the matrices, how to add, multiply, and all that stuff, how to find the inverse of a matrices. That is a different part of this chapter. And the second part is transformation. So right now I'm concerned with the transformation part of this chapter. Okay, so let me talk about transformations. Now these transformations, okay, is nothing but you can understand this in a way that you have to change, or you have to orient, okay, the shapes or the objects, okay, and find the new shape or the new object. Okay, so this transformation is nothing but the change in the figure or the object or the shape of the object, whatever you call it. Okay, and getting a new figure or a new object. Okay, so transformation basically involves object, okay, and image. Okay, so you will be having some object of some shape, okay, regular or irregular, whatever it is, and that object will undergo some changes, some transformation, and it is going to give you a new object or a new image, you can say. Okay, so object and image are the 2 parts of any transformation, right? Now transformations can be of 2 types. Okay, one is something called simple transformation, and B is something called combined transformation. Now again, this combined transformation, we'll be studying only after understanding what are simple transformations. Okay, so transformations can be divided into 2 categories: simple and compound. And I'm going to start with what is a simple transformation. Okay, now simple transformations can be of 4 types. Okay, again, simple transformation can be of 4 types. First one is something called reflection. Second one is something called rotation. Third one is something called uh, translation. And the fourth one is something called enlargement. Enlargement. Okay, these are the 4 simple transformations: reflection, rotation, translation, and enlargement. Out of these 4 simple transformations, today I am going to deal with this one, that is the enlargement. Okay, of course I am going to you should know this reflection, rotation, and translation as well. But today I'm going to start with something called enlargement as a transformation, simple transformation. So coming to the point, first of all, what is a enlargement as a transformation? Okay, so as a transformation, enlargement is what? Suppose an object is given to you. Okay, it will undergo a transformation, okay, whose name is enlargement. So I will call it as capital E. Capital E is an enlargement. It is representing enlargement transformation. Okay, now this object will undergo enlargement and it is going to give you a image. Okay, so whenever an object undergoes any transformation, it will create an image. Okay, now your job is to find out the image once the object is given, applying that particular transformation. That is one type of a question, or one type of a you can say, you can start with that. So if an object is given, how to find out the image. Okay, so we'll start with that simple thing. So object will be given to you, enlargement, you have to perform this enlargement transformation and find out the image. Okay, fine. Now this particular enlargement transformation, okay, it leads to two things. Okay, it will either give you a bigger image, or you can say a magnified image, a bigger image or a magnified image. That means, actually the object size, the image size will be bigger than the object size. Okay, but then it can also happen that the enlargement can give you a smaller image. Okay, or you can call it as a diminished image. Okay, D-I-M-I-N-I-S-H-E-D, diminished image. Okay, so both the things are possible, right? Now another thing, so you have to remember this: enlargement can lead to an object giving you a bigger image or an object giving you a smaller image. That can happen. Another thing that can happen is the enlargement, the object and the image, object and the image, they can be on the same side or on the opposite side. Okay, now these are the possibilities. Now I'm giving you all the theoretical aspects of this enlargement. Okay, right. And this particular enlargement transformation has two parameters. So enlargement transformation has two parameters. Okay, what are they? Number one is something called scale factor, SF. It is known as scale factor. And number two, there's something called center of enlargement, CE. This is known as center of enlargement. Okay, so there are always these two factors, both these factors or parameters, you can call it factors or parameters. Okay, these two parameters, are both very much essential for defining or describing this enlargement transformation. Both are important. Now what is this center of enlargement and what is this scale factor? Okay, to make you understand what is the center of enlargement and what is this scale factor, let me give you this simple example. Suppose you have this particular letter T. Okay, now this is your object. Okay, this is your object. Now somehow this T undergoes a enlargement transformation. Okay, and you happen to get a bigger image, bigger T. Okay, from smaller you are getting a bigger T. Okay, now this is the object, this is the image. I told you enlargement can lead to two things: the object giving you a bigger image or an object giving you a smaller image, right? In this case the image is bigger than the object. Okay, now what happens is, this particular object and image may have a center of enlargement. Center of enlargement is a point. Okay, so suppose that point is somewhere over here. Now this is your center of enlargement. So what happens is the center of enlargement is one of the parameter which you will always find, okay, in a enlargement between an object and an image. There will always be a center of enlargement, and there are two cases. Case one, as I told you, the object and the image, they both will be on the same side of the center of enlargement. Okay, that is, I told you over here, same side. Okay, now this is the case where the object and the image both are on the same side of the center of enlargement. Or it may happen that the center of enlargement is between the object and the image. Okay, so that is also a second case, case two. Okay, so this center of enlargement is something which is an important parameter. It will always be in an enlargement transformation. The object and the image will either be on the same side of the center of enlargement, or they will be on the either side of the center of enlargement. So center of enlargement is one of the parameters which is very important. Let us talk about what is scale factor. Now scale factor is a number. Okay, what is scale factor? It is a number. Okay, so scale factor is a number. Okay, now this number can be, okay, it can be positive or negative. That is one category, one classification. The number can be classified into positive and negative. Second thing is, it can be a whole number or an integer, or a fraction. It can be integer or it can be a fraction. In the case of fraction, it can be improper fraction, or it can be a proper fraction. Okay, so for a scale factor, there are so many possibilities. For example, a scale factor can be +3, a scale factor can be -2, a scale factor can be 3/2, a scale factor can be half, a scale factor can be -half, a scale factor can be -2/3. Okay, so all these various possibilities are there. Okay, now what are the meaning of this scale factor having different numbers? Okay, and the numbers are, some are integers, some are fractions, some are proper fractions, some are improper fractions, some are positive, some are negative. So considering this positive or negative, and considering whether they are integer or a fraction, whether it is proper or improper, you can tell something about the enlargement. Okay, now what are those things? Let me tell you. When the scale factor is positive, okay, when the scale factor is positive, it implies, it means what, you know, both object and the image are on the same side of the center of enlargement. This is the meaning of it. So whenever you have a positive value of a scale factor, you will always see that both the object and image are on the same side of the center of enlargement. Obviously, when it is negative, the object and image will be or are on the either side, or you can say opposite side. Opposite side of center of enlargement. Okay. Next is, if it's a whole number, okay, if it's a integer, if it's an integer, or if it's a improper fraction, then what it implies. So suppose the scale factor is an integer or an improper fraction. Okay, you know what is improper fraction? Numerator greater than denominator. Then if it is an integer or a improper fraction, the image will always be greater than the object, or you can say that the image will be magnified always. And if the scale factor is, suppose, a proper fraction, now in this case the image will be diminished, it will be smaller than the object. Okay, so if there's a combination of sign and the type of a number, that is a proper fraction, improper fraction, or an integer, you can tell what is happening to the image. Okay, suppose you have a scale factor as +3. What I can tell you definitely is, because the number is an integer, okay, so the image will be bigger than the object, that is sure. And because it is a positive, it is having a positive sign, that means the object and the image both will be on the same side of the center of enlargement. That is the meaning of this scale factor +3. Same way, if the scale factor is -2, minus indicates that the object and the image, they will be on the opposite side of the center of enlargement, and the number without the sign, okay, without the sign, the number is an integer, it is 2. 2 is an integer. So this says that the image will be bigger than the object, or the image will be magnified. Object will be having a bigger image, right? Size of the image will be bigger than the object. Suppose you have a scale factor of 1/2. Okay, now here, when there's nothing in front of that number, that means there's a positive sign. Okay, so let us say that the scale factor is +half. Now this indicates that half is a proper fraction. Okay, 1/2 is a proper fraction. If you consider only the number without the sign, it is a proper fraction. So proper fraction means the image will be smaller than the object, or you can say that the image will be diminished. And because it is having a positive sign, that means that the object and the image both will be on the same side of the center of enlargement. Is that clear? Same way, if it is -2/3 or -1/2, okay, the object and the image will be on the opposite side because of this negative sign, and the because it is a fraction, the because it's a proper fraction, okay, the image will be smaller than the object. Okay, so these are all the theoretical aspects about the enlargement that I have discussed with you. Okay, and I have tried to explain you everything theoretically. Now, one by one, when we solve the exercise from this David Renner book and some of the problems from the exercise from this David Renner book, you will understand the concept properly. Okay, so this was just the theoretical explanation of this concept. Okay, and now I will come to the practical problem solving. Okay, so for practical problem solving, I will have to take you to some of